Shima Metal fiscal year 2017 SR&ED project. The project was basically developing a system, an approach to manufacture these shims that we see here. The shims, they come, pay attention, they come with different sizes. Some of them has 3 slots, some of them have 4 slots, different height, different weight, different thicknesses. These one obviously they are coded, but when they receive the coil from the supplier, all these come with a strip of coil, and the coil are typically rolled. And the problem that they experienced was, still I believe you would see in this picture, I'm going to zoom in, you will see this particular one still is bowed. There's a tiny curve in it. This tiny curve was a major problem, because A, has to be complete flat, and 2, this bend would cause it to jam into the die, could not exit. So it created a major problem. To resolve this problem, they did an extensive investigation and trial with the die modification. Finally, by changing the die material type, which all were specified in the interior notes enclosed with this video, they could resolve it. But they reached another problem which much bigger than this. They could solve the problem, they could produce the part shims that were super flat, they could meet the spec. But that flatness caused another set of problem, because if they are really flat, all these would stick to each other and they could not easily move forward, get advanced into the process, and they couldn't even exit because a bunch of them they were stick together. Initial idea was that, let's move forward in the picture so you can see, here we go. There is a pen, so you can get a mental picture the size of them in reference to the pen. They're pretty small and very fragile to work with. Tiny little pressure could twist them and warp them. In this picture, I'm going to zoom in so you can see, pay attention to the thickness of 2 different shims. The problem the industry standard was to make one type of shim was pretty easy. The thin wall is pretty easy to make. Or to make a thick wall is pretty easy. They make only one die to make only the thick one, or make one type die to make the thin one. But to create one die to make both, nobody made it so far. So it was a main challenge. At the same time, they had to meet a throughput of 80 pieces per minute. So it's something like 1.2, 1.25 parts per second. This is the die, as you can see, punches. Different angle of the punch. To prevent these cut pieces from sticking to each other, initially said, let's hypothesize by introducing a spring mechanism, spring plunger into the die, so the spring would basically insert or apply tiny force to each cut parts, exit them from the process. They did a series of experiments with one spring system instead of one, setup 2. Finally, they realized by setup 6, they could reach their goal. They could basically prevent the parts, cut parts, from sticking to each other, and they can advance through the manufacturing process. But the problem that they had with this plunger system, as you know, because it's a mechanical application, these spring plungers, as they were pushing it in order to separate the parts, they made tiny dents into the parts, and those dents, which were unacceptable, they had to finally abandon this approach, pursuing a new way. First approach of a new way was just air blow at them. By doing the air blow, they got limited improvement. Finally, they decided to integrate the air blow system into the die itself. You go to the next picture, here we go. They introduced a set of 3 air blow. Initially started with 1. Here, this is a picture that you can get a mental picture idea. Initially started with a set of 2, then went with a set of 2, then set of 4. Then finally I realized having a 6 dual air, they are going to apply even pressure to the cut parts and they could separate them, prevent them from sticking to each other, and they could basically advance. So that's pretty much it. Look at the notes. This is a big project, lasted in pretty much entire year, 11 months project.